Hi, everybody. Thank you so much for joining us today for our webinar on enabling secure queries and consistent governance and compliance. We have our speakers today. If we want to flip to the next slide. Bill Brooks, the Director of Solutions Engineering at Privacera, and Claudius Lee, our Product Manager, Engine and Security. Quick overview of the agenda for this afternoon, or perhaps morning or evening, wherever you may be. I forget this is a webinar. This is your welcome. We then have our Starburst overview with a demo, Privacera overview and a demo, and we'll have a live Q&A at the end. So the Q&A portion, there's a question box that you all will see on the next slide. One more, did a little fancy thing there. It will pop up and you can ask your questions in there at any time. We'll now hand this over to Claudius.
Hi, so thank you very much. We're going to be covering some of how Starburst interacts. Do I not have this? If you know, looked like it switched on me.
It looks good.
Now we're back. Yeah, so we're going to assume that you know some of the basics of Starburst and some of the basics of Ranger and Privacera, and talk a little bit about the interaction between the two. But just to make sure that we're all on the same page, I'd like to cover at least the high-level overview. So Starburst is a high-performance SQL query engine, and when we're talking about why people use Starburst, we typically concentrate on 5 major areas. Number one, of course, is the performance angle. The whole reason that that the software was built in the first place was because Facebook had an awful lot of data, and their engineers were getting in about 6 queries on a good day. And so there was a really serious effort to try to improve that, and we've the original versions were actually so fast that they temporarily crashed the Facebook network, so we try not to do that. But we want to make sure that you can use all of the available bandwidth and compute resources to actually get your queries back quickly. The second area that a lot of people are looking at is connectivity, right? The ability to query data from a whole bunch of different data sources and bring it all together. The third area is that you need to keep this data secure, not only for legal reasons and compliance reasons, and but also, you know, because often it's company proprietary data, or it's data that for something like PR or marketing reasons you wouldn't want to get out. Fourth, we recognize that reasonably products like Starburst are going to be part of a typically fairly sophisticated technology stack. And we want to make sure that it's as easy to use and watch and configure and upgrade and so on as possible, so that you don't have a big operational burden in actually getting these benefits. And finally, for any serious enterprise usage, you're going to need enterprise support that goes along with that. And Starburst provides that 24/7 by people who really know Starburst inside and out. And in many cases, it's, you know, the original authors of Starburst, and they have quick access to all the developers who are working it and building it for you. So the area that we're looking at often is that we've been there's a trend across the industry to move from a single point of truth to a single point of access. And there's a number of reasons there. We're not going to go into all of them, but it could be cost savings, it could be avoiding vendor lock-in, it could be avoiding the work and the burden of having to move large amounts of data, because realistically you're going to keep getting new data sources, whether it's some shadow IT, maybe it's because certain data sources are better suited towards certain tasks than others, or in many cases there's acquisitions, and those acquisitions bring a wealth of data sources with them. What this ends up looking like architecturally, I just want to walk you through this at a high level. You have some sort of on the left here, some sort of business intelligence tool. Now, this could be a tool like Looker or Tableau or Insights. It could be something like just code, which needs to access a database via JDBC, ODBC, something like that, or it could be some sort of command line tool. I'm going to be showing you some stuff using dbeaver later to a similar tool. Your query comes into the coordinator, which can of course be made redundant for load balancing purposes or for HA purposes. That then gets spread out to a whole bunch of worker nodes, which do the actual communications with the underlying data sources. And they have a series of connectors that will look at the actual data sources, issue the queries to them, bring it back, aggregate everything in the coordinator, and ultimately present it back to the client and the analyst who's going to be using it. So now let's get to some of the meat of what we're talking about here today. These various data sources, of course, have to be secured. And the direction that we headed in is to try to centralize this as much as possible. You can, of course, use Ranger, but as of last quarter, we offered the ability to integrate out of the box with Privacera if you're using Starburst Enterprise. And the way that works is when a query comes in, Starburst will actually communicate with Privacera to make sure that all of the authorization is squared away, that the user who wants to access data is allowed to access whatever it is they want to see, and that they can only see the portions or update the portions and so on. Then based on that, the query gets passed through, and we can secure all of our access permissions in a single place. So let me pause briefly before we move on to the demo and see if there are any questions coming in up till now. If not, we're going to move into the demo. All right, then let's go over here. So let's start with just showing what this looks like basically. So I've set up a test environment. It's on another machine here, and I've set up 3 accounts here. And just for the ease of the demo, so you can see what's going on more easily, the big boss account is an account which has access to everything. And then we have some other people who we want to slightly restrict their access. So we're not going to show everything that you can do with Ranger and Privacera right now. That would be way too much. But I want to show you specifically the key areas on data masking and row filtering. So we can imagine here, we've created a little dummy database here with some employees. And if I show you this right quick, we can select this table and we can see we've got 4 employees in our company. Now, we've got 2 immediate problems here. One is obvious to everyone that we've got something called secret code, and it's not so secret if everyone can read it. So we want to make sure that you can't see this if you're not supposed to. And number 2, we've got 2 different departments here. We've got sales and we've got cryptography. And the cryptography department, of course, is secret, and you may not want people to see these rows within the department if they don't belong. So how are we dealing with this? Let me switch over to Ranger for a second so you can see some of these actual policies. Here. And we can look at some of these policies here. So first of all, I've created a security policy here, which is pretty unrestrictive, right? We have our 3 users for our particular demo here, the big boss who gets to see everything, Trent, who gets access to see also the users who are in the cryptography department, and a sales guy who should not be able to see these people in the cryptography department. So first of all, let's look at the policies in and see how we can restrict access to this one particular table. Now, of course, what should be obvious from here is you can set different tables that people have access to, and you can apply this to groups and so on. We're going to do this on an individual user base just to keep things simple for today. So first of all, let's look at, we'll do row filtering first. So we want to make sure that our sales guy cannot see the people in the cryptography department at all. And if we look at the policy here, it's a very simple setup. We give it some arbitrary name. We tell it which schema this filter applies to and which table, of course. And then we say, well, within who it applies to, of course, in this case, it's sales guy. It could be some group or an entire role. It's going to apply to selects, right? The row filtering is what you can see. And this is essentially a where clause. So if the department is sales, then our sales guy is going to be able to see it. So what does this look like when we actually run queries on it? So let's switch over here back to dbeaver. So if we look at sales guy here, and if I just pop up the connection for a second, you'll see I'm logging in as sales guy. And we'll refresh this so that we're back in. And so we saw Big Boss gets to see everything. If we switch to sales guy here now and use the same restricted schema, we can show the tables here. There's only one table, the restricted table. And now when we do the same select all, which should show everything, except it's not showing the cryptography department rows because we've explicitly filtered those out. So what about these secret codes? Because we're still showing these secret codes, and that's not so great, right? So let's assume now we have a slightly different user. Let's go back to Ranger here. This is actually Privacera without the Ranger, without the Privacera UI on it. Bill is going to have the much more extensive demo of Privacera, so don't worry about that. So now we're going to go into masking. And for masking, we've got a couple of options. So again, we're going to say we got to give it some name, tell it which schemas and tables it applies to. But now we also need to supply a column name, because if we're going to mask a column, we need to say which one it is. In this case, we want to apply this to our user Trent. Trent is, we trust Trent, of course, and Trent is allowed to see all the users, both in sales and in cryptography. This is also going to apply to selects, because this is the data that you can see rather than what you can update. And we have a few different options on how we could mask this. I chose hashing. You could redact it completely, show the last four, the first four common masking techniques that you'll see. And we applied this filter. So what happens now if we go back to dbeaver, where is it, right here, and switch to Trent, right? If we look here at the connection again, Trent is our user. Let me cancel that and make sure we refresh the connection so we're not accidentally in something else. And now, well, we'll be able to use the same queries, because that's the whole point, right? It shouldn't matter we're not forcing people to use a specific query. We're going to be filtering this at the level of Ranger, so we don't need to trust the user to ignore certain data. So we're going to use that, again, show the tables. We still only have our restricted tables. And now when we do our select all, we see all of the rows because we haven't filtered the rows at all for our user Trent. And instead of the secret codes, which, if you recall here, were fake social security numbers and a famous telephone number, instead we see gibberish, which is exactly what we expect to see. So that is a brief overview of the kinds of things that you can do with the row filtering and column masking capabilities. And now I'm going to turn it over to my colleague Bill here, and he's going to do a deeper dive into Privacera itself.
All right.
Make presenter. There you go.
Thank you, Claudius. Appreciate it. Let's bring up a screen here. And you should now be able to see my screen. Folks able to see? Claudius? Excellent. All right. So let's come back in and take a little bit of a look at Privacera and how we've been working with and continue to work with our colleagues over at Starburst. So like Starburst, we come from a long open source tradition. The founders of Privacera actually originally built Ranger as XA Secure way back in 2012. They were acquired by Hortonworks and then open sourced XA Secure as Apache Ranger, and then added to that stack a number of other tools, including Apache Atlas and a variety of others. In 2016, seeing the demand of increased regulatory environment and seeing the move from legacy monolithic Hadoop stack to a much more cloud-based and modern data management architecture, the same founders came back to Apache Ranger and using the framework that it was built on, that incredibly extensible connector-based framework and plugin-based framework, added to it everything necessary for a modern cloud-based data architecture. So the tools that you're familiar with from places like Databricks, Starburst, cloud vendors like Amazon, Microsoft, and Google. The platform went GA in 2017, and this year we launched our platform as a service or software as a service offering, Privacera Cloud as well. And now we have multiple customers in the Fortune 100 and dozens of customers in the Fortune 1000. We have really one area that we aim to meet, and that's solving for this governance blind spot. The ability to not only see policies, but manage and audit those policies across your entire IT infrastructure. Very similar to the way that Starburst is used to get at all of your data assets from a single query interface. Privacera provides that same sort of centralization for the access control and for sensitive data discovery, so that the data consumers, the folks that are using those tools, can find the data they need, get access to that data, and then be monitored and audited as they use that data to make sure that it's being used in the right ways. Privacera adds to open source Apache Ranger with broad centralized access control, including for those cloud native platforms. Automated sensitive data discovery, a Spark-based data discovery module that can go out and scan all of your data assets and identify data elements, classify them, and use that for auditing and access control. Compliance workflows, which can take action on those classifications. If data is classified as PII in a place where it shouldn't be, raise an alert, block that data from being accessed, encrypt that data, and to support that, full-blown enterprise-grade encryption tool. The architecture, again, is based on Apache Ranger. Ranger itself is used as the policy store and integrates with many of the tools that have chosen Apache Ranger as their access control management platform, including Trino and PrestoSQL and Starburst adding to that significantly this year. And then layered on top, we add our discovery and classification engine, our own tools around the access management, which add reporting and audit capabilities to Ranger, and the encryption and masking capabilities. In addition, our Privacera Cloud product is adding monitoring alerts across the entire platform. And we can extend that single Apache Ranger pane of glass into both legacy on-premises systems, if you do have that Hadoop stack still running, either on-premises or in the cloud, as well as cloud native resources, again, across Google, Amazon, and Microsoft, and large scale cloud deployed platforms like Databricks and Snowflake. So let's take a quick look at why there's some strength and some advantage to bringing Privacera and Starburst together. Every enterprise is diverse. You have a variety of file stores, object stores, you've got databases all over the place. No one is ever going to replace everything with a single data warehouse, as we used to say 15 years ago, or data lake, as we used to say 8 years ago, or a single cloud-based platform, as we tried to say a couple of years ago. This all has to coexist. And to be able to have a centralized pane of glass for data governance, access controls, sensitive data discovery, and encryption, have centralized access where you want it using Starburst so that all of your analysts can come in and use a single set of tools, a single SQL dialect to have really high performance queries across all of that data, but maintain that direct access where you need it for your legacy applications, for your high risk applications that are already directly connecting to relational databases or something like an S3 API. And so we bring that combination together and give you both the power of Starburst's distributed query architecture, that high performance centralized query tool, as well as the ability to manage and audit even the access that falls outside of that realm. So I'll pause there before we go into the demo. Do we have any questions coming in? All right, well, let's take a look at Privacera. So coming into Privacera, we'll begin with the pieces that'll be familiar from the first part of the presentation earlier with Claudius. So our basic access policies are traditional resource-based policies. And as you saw in Apache Ranger, a very similar layout. What we've done is add to that open source stack additional policies for things like Athena, Lambda, SQLDB, and Azure Synapse, Power BI, Google Cloud, and of course, the Starburst Enterprise Presto policies as well. In addition, we have the ability to manage tag-based policies. So these are policies where we've applied a metadata tag to some data. So for example, we've decided that a code of ethics certification, some sort of training is required before this data can be accessed. And we're going to block access for all users who don't have it on all of our data sources. So in this case, the policy right now is just set for AWS Athena, but we could very easily add data that's tagged in your Starburst instance, data that's tagged in your Hive instance, and block that same access across all of those resources at once. So in order to get those tags created, Privacera brings its sensitive data discovery module. We first set up the data sources so that we can identify what exactly we're going to be scanning. So for example, we might be scanning a claims database. Through Starburst, we might be scanning particular databases or tables in something like Snowflake. We're scanning S3 resources directly. Once we've identified those, we can scan those in near real time as the data changes, or we can schedule those resources to be scanned on a periodic basis. Privacera is built on a Spark backend for the data scanning, so it scales nearly linearly. We have customers that use this tool to scan 20 to 25 petabytes of data and scale out horizontally on, in their case, Databricks Spark and Hadoop to scan that data on a periodic basis. And it scales out quite nicely because the actual scanning is done on the Spark cluster itself. Once we define the data sources, we identify the tags that we want to find in that data. Might be something like credit card information, dates of birth, or email addresses. And then we combine three tools together. Dictionary matching to identify known values in the data or keywords that may be found within the data, as well as lookups that are used to find known values. Things like criminal record numbers, account numbers. That helps to reduce false positives and ensure that we get a good match. We combine the dictionaries with pattern matching. We include a number of these in the package, and these can be customized as the customer needs. Again, many of these can be quite complex, but they're expressed in regular expression, and regular expressions have some limitations. They don't do calculations particularly well, so things like check digits or ensuring that values fall within a particular set of known values can be either very cumbersome or just impossible to do with a dictionary or a pattern. So we add to those our heuristic models. And these add things like specific information about dates of birth. So we can look at the range that may apply to your industry. If you're a pediatric hospital, something that represents a birth date may be quite different from if you're a retirement firm. We can also apply algorithms, such as in this case, looking at the distribution and frequency to determine whether this is more likely to be a date of birth or something more like a transaction date. Similarly, a credit card check can include the LUN check to be able to determine whether a value is actually a credit card versus something that's just formatted like one. These are combined together with a set of rules. These can be applied to both structured and unstructured data, and then they can be mapped directly to tags. There's quite a bit of flexibility here, but we do ship with most of the standard pieces implemented directly out of the box. Once the scans have run, we're able to see what that status is and develop a dashboard that shows where your data resources are, what types of information are found there, and get a sense of your exposure to risk depending upon where different data elements are located. Things like social security number, person name, credit card information, etc. Those scanning results are brought together into our data inventory, which gives you the ability to view the scan results, view specific tag numbers, potentially search by a tag. So if you wanted to find every place that a social security number had been identified in your enterprise, we could look here. Tags that have been applied tentatively, maybe not meeting the thresholds, can be manually reviewed. They can be accepted or rejected and a reason code given. You can view some of the original sample values that were used and the type of match that was made. In this case, neither one of these columns has a real name, C3 and C6. We can identify that both of them look like they might be social security numbers, and the heuristic model has said that, yeah, 63% of the ones in the C3 match. And our data steward has come in and said, yes, those in fact are social security numbers, whereas column 6 is really just an account number. Might have some overlap, so they've rejected it. Accepted tags are then used in tag-based policies, so you can block or allow access to data based on those tags, and that passes right straight through into Starburst, not just in the Hive catalog, as in open source Presto, but across the entire system catalog and all catalogs that are included within Starburst, and we'll take a closer look at some of that in a moment. In addition, because we have those classifications, we're then able to apply compliance workflows, which can take data in a particular zone, say data that we know we have to apply a right to be forgotten to. We can pick that data up, scan for information that we know has been, where are we here? Scan for information that we know has been certified as being a real right to be forgotten request, and then apply, in this case, a redaction scheme to remove the personal information. We could also apply encryption or remove the records entirely. Similarly, we can raise alerts based on disallowed movement or tags. We can move data from a landing zone to a curated zone. We can throw alerts based on where that data access is coming from, and we can expunge or encrypt data on the fly in places like AWS S3, Azure ADLS, or Google's GCS, Google Cloud Storage. The encryption is managed through our encryption engine, where we provide a set of predefined schemes, and then you can define your own here. We allow the schemes to be pretty flexible, including different formats for format preserving encryption, different encryption APIs. We include our own and the open source Bouncy Castle, which is FIPS 140-2 compliant in the box, and we can extend that as well depending on your needs. And then a variety of algorithms that can be applied. Hashing algorithms, 256-bit encryption, format preserving encryption, etc. And then those tie back in to our access management policies. We can have a tag-based policy or a resource-based policy that can use the tag to either allow or deny access or provide masking or encryption. So in this case, I have a masking policy that says if I encounter a medical record number, I want to hash that value. I can also use our encryption algorithms to encrypt that as well. In this case, I'm just applying a hash. This will apply a SHA hash to the value here, and then we can apply that in real time as the data is selected. So we can take a quick look at how some of these might work. So if we pull up everyone's favorite query tool, dbeaver again, and let's do some queries. In this case, I'm looking at some medical claims, and I have the NPI, which is the physician identifier, the practice identifier. We're just going to run a quick query to summarize the paid claims against the patient, the NPI, the patient identifier. We'll let that run. And while that's running, we'll take a look at what's actually happening in the background here. If we look at the audit trail, we can see all of the access as it's been happening and see every attempt at access and the results of that access. So here's our user, Emily. She's attempting to look at claim amount, primary payer, a few other columns. And we can see that the access has been either allowed or denied, and the policy that's allowed that access to happen. So we can click directly through, see which policy, and we can look at a complete history of that policy. We have a full audit trail. So that auditability extends across all of the services. If you wanted to include, say, direct access to S3, we can look at something like that. We can exclude certain users and drill back in. Let's take a look at our dbeaver again. See what we have here. Looks like I have a connectivity issue. Let's reconnect here. And let's try that query again. Now it looks like my instance has gone down, but let's take a look at what we've got in the policy itself. So what we've done, because we have the ability to control both Hive directly and Starburst more generally, we have policies at both levels. In this case, we're looking at our sales database and customer database in policies that are held against Hive, and we're looking at policies at the Starburst Presto level across the rest of the catalogs. So for something like Oracle, we're able to grant access at the catalog level to allow users to query the Oracle catalog itself. And then we're able to get down to the schema, table, and column level. So in this case, I've granted users in our clinical group the ability to select from the claims outpatient table given them the ability to select the patient identifier. However, in this case, I've also said that we want that patient identifier to be masked, so we'll enable that policy here. And that same group is still able to select, but now we'll add that hash to the same query. So it looks like we're having some network issues on my end. We'll figure out why that is in a bit. But for the moment, why don't we open up and ask for some questions from the audience? Becca or Mandy?
Yep, I'm seeing one question. This one is, what happens if the underlying data source has its own authorization restrictions?
An excellent question. Claudius, you want to pick that one up on the Presto side? Then we can talk through the Privacera side as well.
Yep, of course. Am I? Yeah. So that's a great question, because sometimes they come with their own authorization sets. The answer is it's going to use the most restrictive. So by default, if one of them says you can use this and the other one says you can't, it's going to say you can't.
Exactly. And then what we can do is use Privacera to manage permissions directly in many of those platforms. So if it's something like, say, Postgres or S3, we can use Privacera to audit the service account that might be connecting and to audit any connections, audit and control access for connections that can't come through Presto. And that way you get the best of both worlds, that user level security across all of the queries that span connections in Presto, as well as the ability to look at those service accounts that tools like Presto might be using to connect through, or that applications that are left in place might be using to connect through. So it's a nice crossover, nice synergy between the two. Great question. Any others?
That is it for the questions. But I would like to remind everybody that Starburst is hosting our first ever large industry conference, virtual of course, February 9th and 10th, called Data Nova, and Privacera is a great sponsor, and we'll be doing a lightning session. So I'm going to put into the chat how to sign up. And if you have any other questions, we'll be sending an email out with follow-up information, so please feel free to reach out. Any
right,
last
excellent. Thank you, Mandy.
words? Great. Well, with that, we will give everybody a little bit of time back in their day. Thank you guys so much. We appreciate this. Definitely learned a lot.
Thanks everyone for attending. Appreciate your time, particularly today. Thank you, Claudius. This has been great to put together, and looking forward to working together more in the field as we expand this.
Thank you. Likewise, Bill.
All right. Take care, everyone.
Bye.